Hello everyone, my name is Suman Bharti and I'm third semester Master's Student in Computer Science. I completed the State to Study course under the supervision of Dr. Tekas. Our research project is wrist intent recognition for stroke rehabilitation. Our research is basically applicable for stroke rehabilitation robotic device which is basically designed for impaired stroke survivors to regain hand function. There are two problem statements for us to work upon it. Generally, the stroke therapy is quite expensive, and the second one is like limitation of stroke rehabilitation robotic devices, which utilizes actuators kinematic sensor. But the problem is they do not benefit the severely impaired stroke survivors who have very limited or even no motions on their limbs. So our goal is to find the cost-effective solution to minimize the stroke therapy. And but obvious the easy availability of stroke therapy with maximum benefit. Since we do not have to compromise the cost against accuracy, so our goal still is to achieve the higher accuracy with automatic high-level feature extraction and to assist the severely impaired stroke survivors who have very limited motions on their wrist. The good thing is we accomplished our goals. We utilized a bioelectrical EMG signal to capture the wrist intent motion of severely impaired stroke survivors who have very limited motion. Since this is an application-based project, so we utilized publicly available EMG dataset for hand gestures from UCI machine learning repository to accurately predict three basic wrist motion: extension, flexion, and no motion. This particular dataset uses MyoArm device to collect the data from 8 channels. And we optimized 8 channel dataset to 4 channel dataset and find 4 channel combination 1458 which generates the best classification accuracy. We also optimized window size and overlapping window size with 100 milliseconds and 50 milliseconds. Based on the literature review on many different classification algorithms, we find it out one-dimensional CNN has recently become the state-of-the-art technique for crucial signal processing application, and this is why we adopted one-dimensional CNN as our base model. So, is the solution cost-effective or not? For this application requirement, one-dimensional CNN is very effective where the location of feature is not of higher relevance. Real data and low-cost hardware implementation is feasible using one-dimensional CNN. There are numerous advantages of using one-dimensional CNN on raw signals since it does not require any pre or post processing, for example, feature extraction, selection, dimensional reduction, and denoising. Moreover, they are highly noise-resistant model and they're able to extract very informative and automatic features which are time independent. Our design is very simple and it is designed using Keras deep learning library. The input shape is 100, 4, where 100 represents our optimum window size and 4 represents optimum sensors. We used VGGNet as the model architecture. We took 2 stacks of convolution layer followed by the max pooling layer and another 2 stacks of convolution layer followed by average pooling layer. And then dropout layer is added before the dense layer. We trained the network with 78 by 22 trained and trusted dataset with the 400 batch size for 50 epochs. The reason of doing so is like dataset contains 36 subjects, so dataset with subject number less than or equal to 18 considered as a training dataset and dataset with subject number greater than 18 considered as testing dataset. So finally, we achieved the classification accuracy of 97% to predict the three basic wrist motion, extension, flexion, and no motion. And below is the glimpse of our confusion matrix. So the final note is our developed model increases the functional capability of a stroke rehabilitation robotic assistive device with the highest gesture classification accuracy with low cost hardware implementation of the model. Thank you.